Welcome to VSS Monitoring's podcast series, the podcast series dedicated to helping you, the network professional, increase visibility to all of your users and lowering your costs while doing so.
Hello and welcome to the VSS Monthly Podcast. My name is Mark Larucci and I'm an account support engineer here at VSS. I'm joined by Brett Green from our engineering team. Today we're going to talk about load balancing. Well, let's get started. Our distributed taps are the focal point of our product portfolio. With intelligent features such as selective aggregation, filtering, load balancing, and remote management, and also the ability to not only capture passive traffic, but also from span ports. The focal point of today's podcast will be load balancing.
Many users are familiar with load balancing in a networking environment. The ability to load balance across servers or across multiple networks is important to them. However, what we do in a tap is distinctly different. When we consider load balancing in a tap or span tool, we're actually talking about load balancing the monitor traffic on the device. So today we'll begin by defining load balancing and how it differs from filtering and traditional load balancing. Then we will discuss its benefits and applications, and show how it fits into a VSS traffic capture architecture. Finally, we'll note where you can find further information. So what is load balancing in a VSS tap? Load balancing is distributing captured traffic across multiple monitor ports that have been logically grouped. So how is this done? You can identify traffic flows or sessions based on user-defined criteria. For example, MAC destination and source, Ethernet type and input port, or IP destination and source, and TCP UDP destination and source. There's also available other combinations of these same types of user-defined criteria or flows. Each flow or session is consistently delivered to the same monitor output port within the logical output port group. Load balancing traffic only applies on these monitor ports. The network links are never altered in any way, and the traffic is simply passed through transparently. Depending on how a session is defined in a user's particular network environment, load balancing can usually ensure a fairly equal distribution of traffic across the monitor ports, and of course, sessions are never broken up. So how is load balancing different from filtering? Filtering is passing or dropping traffic, so basically filtering copies network data from the network ports and passes it to the monitor ports based on layer 2 to 4 criteria, such as IP address ranges, UDP-TCP port numbers, other services, or certain Ethernet types, for example, IPv4 or IPv6 packets. And load balancing is an algorithm for distributing that same traffic or other traffic that's not filtered to monitor ports based on those user-defined criteria we discussed previously. Again, just to be completely clear, filtering is complementary but independent of load balancing. Filtering and load balancing can be used together or separately to accomplish whatever type of monitor output data streams the user desires. So what are the benefits to load balancing? It can prevent oversubscription or packet loss in the example of monitoring 10G traffic with 1G tools. It maintains session delivery consistency across multiple monitor ports. And session criteria can ensure that even traffic distribution across a group of monitor ports is guaranteed.
Now let's take a couple examples of how load balancing can be applied. In this example, we have a 10G network being monitored with multiple 1 gig tools. On the bottom, you have a 10G network infrastructure. And the first tool is a 10G monitoring device. As we move across, we have 2 groups of load balanced 1 gig monitoring devices. The first group there in the middle is seeing filtered HTTP traffic. As you move forward to the right, that second group is seeing all the traffic from that 10G network and load balanced to 4 1 gig monitoring tools. What's happening is you're now able to leverage your legacy 1 gig monitoring tools across a new 10G network infrastructure. The second example here shows the monitoring of multiple 1 gig networks with multiple 1 gig tools. you're able to reduce the processing load on any one of your monitoring tools by balancing the traffic across multiple tools, utilizing your existing monitoring devices. Let's take a look at a VSS distributed traffic capture system in a network architecture. At the bottom, we have a standard communications infrastructure with your gateway, your core, access, and distribution layers. Now within each one of these layers, we have different capture points where you want to see the traffic, both inline and span. At the top is our monitoring tools layer with a number of different monitoring tools, 5 in total. In the middle is the VSS distributed access platform, which acts as a bridge between the monitoring tools and the communications infrastructure. What's happening is those blue boxes, which are the VSS taps, are capturing all the inline and span traffic from that communications infrastructure and aggregating it to a central management platform. That central management device is then sending all the traffic to each one of those monitoring tools, allowing each monitoring tool to have an independent view of the entire network. With features such as filtering and particularly load balancing, we're now able to create more visibility, central management of all the data, leverage existing monitoring tools, and lastly, lower mean time not only to repair, but also incidents that happen on the network. Thank you for joining us on our monthly VSS podcast. If you have any questions or would like more information regarding load balancing, please visit us on the web at www.vssmonitoring.com or give us a call at +1 650 697 8770. Once again, thank you for joining us and have a great day.